Greetings everyone, I'm Leana, your guide to the fascinating world of quantum mechanics. Today, we're going to embark on a journey that intertwines the realms of quantum physics with the concept of time travel. We'll delve into the enigmatic phenomenon of quantum entanglement and ponder over the intriguing possibility of time loops. We'll be exploring these ideas and more, all under the captivating umbrella of quantum mechanics. So buckle up as we dive into the quantum realm and explore the possibilities of time travel. To understand time travel, we first need to understand quantum mechanics. Quantum mechanics, in the most basic of terms, is the branch of physics that deals with the smallest particles in the universe, those at the atomic and subatomic levels. It's a fascinating and admittedly, a perplexing field that has baffled some of the greatest minds in history. Unlike classical physics, which attempts to explain the world as we see it, quantum mechanics delves into the realm of the unseen. It deals with phenomena that don't follow the rules we're familiar with in our everyday lives. For instance, in the quantum world, particles can exist in multiple places at once, a phenomenon known as superposition. Another fundamental principle of quantum mechanics is wave-particle duality. This principle tells us that every particle also behaves like a wave and vice versa. This is why light can behave as both a particle and a wave. Then we have quantum entanglement, where particles become interconnected in such a way that the state of one instantaneously affects the state of the other, no matter how far apart they are. Why is this important? Well, these principles are key to understanding the universe at its most fundamental level. They're the building blocks that help us understand everything from the smallest particles to the largest galaxies. With this foundation, we can now delve into the quantum aspects of time travel. One of the most intriguing phenomena in quantum mechanics is quantum entanglement. Imagine owning a pair of magical dice. No matter how far apart they are, when you roll one, the other will always show the same number. This witchery is not far from what quantum entanglement is all about. In the microcosm of quantum particles, two particles can become entangled, meaning their states are interlinked. If you measure the state of one particle, you instantly know the state of the other, regardless of the distance separating them. This spooky action at a distance, as Einstein famously called it, challenges our everyday understanding of reality. It seems to defy the speed limit set by light, enabling the transfer of information instantaneously across vast distances. But hold your horses, this doesn't mean we can send messages faster than light. The information isn't useful until you compare notes with the person at the other end, and that still requires a good old-fashioned slower-than-light communication. But here's where things get even more interesting. Quantum entanglement doesn't just connect particles in space, it also links them across time. In the quantum world, cause and effect can get muddled. An action performed on a particle in the present can affect how its entangled partner behaved in the past. This is known as retrocausality. Now, don't rush off to correct your past mistakes just yet. We're still light years away from using this for any practical purpose. But it does make you wonder, doesn't it? If entanglement can connect particles across time, could this be a stepping stone to true time travel? Scientists are still grappling with these questions and the many paradoxes they throw up. But one thing is clear: quantum entanglement has turned our understanding of time on its head. It's given us a glimpse of a world where time is not a one-way street, but a dimension that can be twisted, turned, and maybe even traveled. Quantum entanglement gives us a new perspective on time, one that could potentially be manipulated for time travel. Now let's examine the fascinating concept of time loops. Imagine, if you will, being stuck in a loop, repeating the same events over and over again, like a record on repeat. Sounds like a sci-fi movie plot, right? But could this actually happen in real life? Let's explore the science behind it. Time loops, also known as causal loops, are a theoretical consequence of certain solutions to Einstein's field equations in general relativity. These solutions describe a universe where time is not linear, but rather loops back on itself. In such a universe, it is theoretically possible for an event to be its own cause, creating a sort of chicken and egg paradox. The idea is not as far-fetched as it might seem. Quantum mechanics, the branch of physics that describes the bizarre behavior of particles on the smallest scales, allows for just this kind of time loop. It's all thanks to a phenomenon known as quantum superposition, which holds that a particle can exist in multiple states at once until it is observed. Consider the famous double-slit experiment. When a particle is fired at a barrier with two slits, it behaves as if it has gone through both slits at the same time, creating an interference pattern on the other side. This suggests that the particle exists in a superposition of states, each corresponding to a different path through the slits. Now, apply this concept to time. If a particle can exist in a superposition of states at different locations in space, then why not at different points in time? The particle could, in theory, loop back in time to interact with its past self, creating a time loop. Of course, this is all highly speculative and has yet to be confirmed by experiment, but the implications are mind-boggling. It suggests that time, as we understand it, might be far more flexible and strange than we ever imagined. Time loops, if they exist, could open up a whole new realm of possibilities for time travel. So, how does quantum mechanics fit into the concept of time travel? Well, let's delve into this fascinating topic. Quantum mechanics, the study of the smallest particles and their behavior, has long been a source of intrigue for scientists and time travel enthusiasts alike. The principles of quantum mechanics, such as superposition and entanglement, seem to challenge our traditional understanding of time. Superposition, for instance, allows particles to exist in multiple states simultaneously until observed. This notion, in theory, could suggest the possibility of being in multiple times at once. Imagine being in both the past and the future at the same moment. Mind-boggling, isn't it? Then there's quantum entanglement, a phenomenon where particles become interconnected, sharing their states instantaneously regardless of the distance between them. This has led some to propose that entangled particles could serve as a sort of quantum bridge, potentially enabling instantaneous communication across vast distances, or even time itself. But of course, there are challenges and unanswered questions. The most significant among them: how do we move from the quantum realm of tiny particles to our macroscopic world? This is known as the measurement problem. In simple terms, the rules of quantum mechanics don't seem to apply to larger objects, like a time machine or even a human being. Moreover, if time travel were possible, wouldn't we already have visitors from the future? This is known as the Fermi paradox of time travel. Of course, some argue that time travelers could be among us, but they're hiding to prevent any time-altering actions. Despite these challenges, the intersection of quantum mechanics and time travel continues to be a vibrant field of research, with new theories and models emerging regularly. While we don't have all the answers yet, quantum mechanics is certainly reshaping our understanding of time and its potential manipulation. So, keep those flux capacitors handy, because the quantum realm might just hold the key to our time-traveling dreams. As we've seen, quantum mechanics offers tantalizing hints about the possibility of time travel. If you've been with us from the start, you'll remember that we began by unraveling the complex tapestry of quantum mechanics, a field that dares to challenge our conventional understanding of the universe. We discovered that quantum particles can exist in multiple states simultaneously, a phenomenon known as superposition, which defies our everyday experience. We then journeyed into the realm of quantum entanglement, where we found that two or more particles can become inextricably linked, no matter the distance between them. This spooky action at a distance, as Einstein once called it, could potentially allow information to be transmitted instantly across vast distances, even across time itself. Next, we delved into the intriguing concept of time loops. Time in the quantum world is not a one-way street. Quantum particles can traverse time in both directions, creating loops that defy our linear perception of past, present, and future. This opens up the tantalizing possibility of time travel, at least at the quantum level. But what does all this mean for us? Well, the implications are as vast as the universe itself. Quantum mechanics could potentially revolutionize our understanding of time, space, and reality. It could open doors to technological advancements that we can only dream of, from quantum computing to, yes, possibly even time travel. However, it's important to remember that quantum mechanics is still a young and evolving field. There's so much we don't know, so much left to discover. It's a field ripe for exploration, for questioning, for dreaming, and that's where you come in. So I encourage you to keep digging, keep questioning. Don't be afraid to challenge the status quo. After all, it's through questioning that we push the boundaries of knowledge, that we venture into the unknown, that we imagine the unimaginable. Thank you for joining me on this journey through the quantum realm. Until next time, keep questioning, keep exploring, and keep imagining the possibilities.